Let us solve one more question. If D is the highest common factor of 45 and 27, find x and y satisfying D is equal to 27x plus 45y. Here there are two numbers mentioned, 45 and 27. The larger one out of them is 45. So let me express 45 as 27 multiplied with 1 plus 18. Let us call this equation as 1. In this step, we don't have the remainder equal to 0, so we need to express 27 as 18 multiplied with 1 plus 9. Let us name this as equation 2. In this step also, we don't have the remainder equal to 0, so further we need to continue and write 18 as 9 multiplied with 2 plus 0. In this step, we have a remainder equal to 0. Therefore, highest common factor is 9. This is the value of D. Now we need to express the value of D in terms of 27 and 45. For doing that, let's write this 9 as 27 minus 18 times of 1. This is from question 2. Now, this 18 can be written as 45 minus 27 multiplied to 1 into 1. This is from question 1. Let us further simplify. Let's open the bracket. We get 27 minus 45 plus 27 into 1. Here we have 27, here we have 27 into 1. So on simplification, it becomes 27 2 times minus 45 is 1 time. Let us compare this with the given expression 27x plus 45y. On comparison, we get the value of x as 2 and the value of y as minus 1. Let's solve the next question. Show that any positive odd integer is of the form 3q or 3q plus 1 or 3q plus 2 where q is some positive integer. Suppose a is any positive integer and b equal to 3. Then by Euclid's algorithm, we have a is equal to 3q plus r, where 0 less than or equal to r less than 3. Look at the condition 0 less than or equal to r less than 3. This implies the value of r can be 0, can be 1 or it can be 2. If the value of r is 0, then in this expression a becomes 3q. If the value of r is 1, then the expression becomes 3q plus 1. And if the value of r is 2, a becomes 3q plus 2. Therefore, any positive integer will be in the form 3q or 3q plus 1 or 3q plus 2. Let us solve the next question. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some positive integer. Like the previous question, let us suppose a is any positive integer and the value of b is 4. By Euclid's algorithm, a can be written as 4q plus r, where 0 less than or equal to r less than 4. In this case, the value of r can be 0, can be 1, can be 2, or it can be 3. If the value of r is taken 0, then the expression a becomes 4q. If the value of r is 1, then the expression becomes 4q plus 1. For r equal to 2, a becomes 4q plus 2. For r equal to 3, a becomes 4q plus 3. Look at the first statement here, a is equal to 4q. It is nothing but a is equal to some 2 times of 2q. So it means that it is even. This a is equal to 4q plus 1, it is even plus 1. So a is odd. Look at this expression. Here we can write this as 2 common. 2 is taken common, we get 2q plus 1. Multiple of 2, so it is even. This one is 1 added to the previous statement, 4q plus 2 plus 1. So it is even plus 1, so a becomes odd. If you clearly observe, in the second and the fourth statements, we get odd positive integer. So any odd positive integer will always be in the form of 4q plus 1 or 4q plus 3. Next question. Show that the square of any positive odd integer is of the form 8k plus 1, where k is some positive integer. From the previous question, we have learned that odd positive integer will be of the form 4q plus 1 or 4q plus 3 or q some positive integer. Now let me take that particular odd positive integer as 4q plus 1. Square of this number will be x square, which is equal to 4q plus 1 whole square. On expanding this, we get it as 16q square plus 8q plus 1. In this, I can take 8 common. I'll be getting 2q square plus q plus 1. Now this x square can be written as 8 times of k plus 1, where k is equal to 2q square plus q, some positive integer. This is for x is equal to 4q plus 1. Now if you consider x value to be in the form of 4q plus 3, let us square this. We get it as 4q plus 3 whole square. On expanding this, it becomes 16q square plus q plus 9. Further, I will take 8 common and write this as 2q square plus 3q plus 1 plus 1. So it is x square, which is equal to 8k plus 1, where k is equal to 2q square plus 3q plus 1 for some positive integer. Therefore, look at this, 8k plus 1, 8k plus 1. So any number, any positive odd integer, when it is squared, it will be of the form 8k plus 1, where k is some positive. Let us move on to the next important topic of this lesson, fundamental theorem of arithmetic. It states that every composite number can be expressed as product of primes. This factorization is unique and it is apart from the order in which the prime factors occur. For example, if I consider some number 10, its prime factors are 2 into 5. This is unique. We can't express in any other prime product. If the order is changed, still the prime factors they remain same. So the factorization is unique and it is apart from the order in which the prime factors occur. Using this fundamental theorem of arithmetic, we have a question to find out highest common factor and the least common multiple of two positive numbers. Let us take an example of finding highest common factor and the least common multiple of 6 and 20. Let me express this 6 as the product of prime, it is 2 into 3, and 20, the prime product is 2 square into 5. Look at the statement here. Highest common factor is the product of the smallest power of each common factor in the given numbers. Among this, to find the highest common factor, we need to consider the product of smallest power of each common factor in the given numbers. The common is 2 and the least power is 1. Therefore, the highest common factor is 2. Whereas the least common multiple is the product of all the greatest power of each prime factor occurring in the expansion of the numbers. Therefore, here I have to consider the greatest power, that is 2 raised to the power 2 into 3 into 5, and this becomes 4 3s are 12 into 5 60. So the highest common factor is 2 and the least common multiple is 60. Look at an important property related to this concept. Here, HCF into LCM will be equal to 6 into 20, product of the numbers. Here the highest common factor is 2 and the least common multiple is 60. This will be equal to 6 into 20. Multiply, we get 120 equal to 120. Let us verify the result. Highest common factor of two numbers A, B into the least common multiple of A, B equal to product of the numbers. Let us take two different numbers. Say A is 510 and B is 92. Let us find out the prime product of 510, which is 2 into 3 into 5 into 17. And for 92, it is 2 into 2 into 23, which is 2 square into 23. In this case, the highest common factor is 2 to the power 1, nothing but 2, and the least common multiple is 2 square into 3 raised to the power 1 into 5 raised to the power 1 into 17 raised to the power 1 into 23 raised to the power 1. On multiplication, we get it as 23,460. Let us now find out the left hand side, HCF into LCM. Here the HCF is 2 into the LCM is 23460. If you multiply this, we get it as 46920. Look at the right hand side, it's the product of the numbers A into B, which is equal to 510 multiplied to 92. On multiplication, we get it as 46,920. Therefore, the result is verified. Remember another important result: the highest common factor of three different numbers into the least common multiple of three different numbers will never be equal to the product of the numbers. Let us take a simple example and try. If we take the value of A to be say 12, B to be 15 and C to be say 21. Let's find out the highest common factor and the least common multiple. For doing that, I'll express this 12 as product of primes. It is 2 square into 3 raised to the power 1. 15. The prime product is 3 into 5. 3 raised to the power 1 into 5 raised to the power 1. 21, which is 3 raised to the power 1 into 7 raised to the power 1. The highest common factor is, which is the common number here, 3. 3 raised to the power 1. And the least common multiple is 3 raised to the power 1 into 2 square into 5 into 7. On simplification, it becomes 420. Look at the product of HCF into LCM. HCF into LCM is 3 multiplied to 420. This becomes 1260. Will this be equal to the product of numbers A into B into C? 12 multiplied to 15 multiplied to 21. It will not be equal. And the product becomes 3780. Therefore, this result is also verified.